This looks like a standard trigonometric equation, but thousands of students lose easy marks on it every single year, not because their algebra is wrong, but because they completely ignore a hidden trap hidden right here in the boundaries. Welcome back to Prime Maths Hub. Today, we are breaking down how to solve quadratic style trigonometry equations step by step, and exactly how to spot the traps before it ruins your exam score. Let's get into it. We have 2 sine squared theta to be equal to 1 plus cos theta. We want to look for the value of theta, given that 0 is less than or equal to theta less than or equal to 90. That is, theta is a value between 0 and 90 degrees. We have 2 sine squared theta on this left hand side, and we have cos theta on the right hand side. The very first problem we have here is a lack of uniformity, sine squared theta and cos squared theta. To solve a quadratic equation, we need everything in terms of the same trigonometry function. Now, we have to note something. Sine squared theta plus cos squared theta is equal to 1. Let's make sine squared theta the subject of the formula. So sine squared theta is equal to 1 minus cos squared theta. So we are now going to substitute this into the equation. So we have 2 into 1 minus cos squared theta to be equal to 1 plus cos theta. Opening the bracket, we have 2 minus 2 cos squared theta to be equal to 1 plus cos theta. So we have 0 to be equal to 1 plus cos theta. 2 crosses and becomes minus 2. Then minus 2 cos squared theta crosses and become plus 2 cos squared theta. Now let's rearrange. 2 cos squared theta plus cos theta minus 2 plus 1 is equal to 0. So 2 cos squared theta plus cos theta minus 1 is equal to 0. Note, cos squared theta is the same as cos theta all squared. So let cos theta be equal to P. Then 2 cos squared theta will now be 2P squared plus cos theta is P minus 1 to be equal to 0. Now we have a quadratic equation. We have a quadratic equation. So we are going to factorize this quadratic equation. We multiply this term by this. So we have minus 2. Then the coefficient of p is 1. So we think of two numbers whose product will give us 2. We have 1 and 2. For us to get minus 2, one of the factors must be a negative number. Then if we are to add and to get a positive sum, the smaller number is a negative number. So 2 minus 1 is 1. Minus 1 times 2 is minus 2. So the factors are minus 1 and 2. So we have 2p squared minus p minus p, then 2p minus 1 to be equal to 0. A common factor of 2p squared and p is p. So we have 2p minus 1 plus a common factor of 2p and 1 is 1. So we have 2p minus 1 to be equal to 0. Therefore, p plus 1, 2p minus 1 is equal to 0. So p plus 1 is equal to 0, or 2p minus 1 is equal to 0. So p is equal to negative 1, or 2p is equal to will be 1 over 2. We're told something in the question. We're told something. Theta, theta is between 0 and 90. Theta is an angle between 0 and 90. Remember that cosine is positive in the first and the fourth quadrant. And since theta is between 0 and 90, it means theta is in the first quadrant. Now, but p, something is equal to p. We said cos theta is equal to p. So since theta is positive, therefore cos theta is equal to 1 over 2. So theta is the cos inverse of 1 over 2. So theta is equal, the cos inverse of 1 over 2 is 60. We rejected 1 minus 1 because that value is not in the first quadrant. Therefore, theta is equal to 60 degrees. So, and there you have it. By systematically changing your identities, factorizing carefully, and respecting your boundary conditions, you avoid the trap entirely. If this step-by-step breakdown made quadratic trigonometric equations finally click for you, make sure to drop a comment below letting me know what topic you want analyzed next. Don't forget to subscribe to Prime Maths Hub for more clear math solutions. And I will catch you in the next breakdown.